Okay, you are recording this meeting. Be sure to let everyone know. Hey, everyone, I'm recording. So here's the good thing, or here's the cool thing. The first module, if you will, is really just an introduction. There's a lot of things. We looked a little bit at the IE, but what's up with that? So we're going to talk more today. I don't believe we'll get through everything. It'll probably be like half of the class like it was last time, maybe for the first lab. I don't know, we'll have to see. But here's a look-see at what we're doing. We're actually starting module 2 today, which is not even visible. So let's go look at it. Okay. Before we get too far here, are there any questions with the module 1 stuff? Like I said, I'll get, hopefully, I don't know, the more I'm saying this, the more it's going to be not feasible, but I will get your assignments graded as soon as I can. On the, my goal is to do it over the weekend. Yeah. And again, it's just really me going to be looking, make sure you set those settings right on your digital multimeter. And as I mentioned before, the reality is that, most times you're just going to be looking for continuity, because that's probably going to be the problem in your circuit. It's not going to be connected. What's up, Anna?
Don't ask if they've invited to the meeting.
Oh, wait, what?
Coltrane?
Coltrane?
Yeah, he has to be invited.
Oh.
Yeah.
Did I, I saw him. Oh, thanks. That ain't gonna work, huh?
I was late one time to an online meeting because in Teams,
Yeah.
the calls were like in the individual module things, where last semester we just did them all in the one.
Yeah.
Yeah.
It should be a little,
Yeah.
the little video thing should pop up and say where it's going on at, yeah.
Yeah, but I figured that out, obviously, that day.
Yeah, because the whole idea, hopefully, like today, we're gonna start talking about module 2, so let's put the meeting in there, and then that way it's somewhat organized. Not to go down a big rabbit hole on this, but the teams changed the way they handle videos, so they're no longer just automatically uploaded to stream, so they're only there for 20 days, which at this point now, their videos from like the first week should be dropping off. So if you haven't downloaded those, you pretty much you do not have access. Although, what do you want to call a diligent, a conscientious, a student in our class that cares about you guys, he started a YouTube channel, just download the videos and upload them. So if we could coerce them when we see them tomorrow, well, we won't be seeing them, we'll be seeing them virtually, but at any rate, ask them about that. Let's see. Oh, speaking of that, there's only a handful of us in here, and this is probably more appropriate for the 315 class. But I've had a few people ask about ACM, because I was thinking in my head, I was like, oh yeah, we'll meet like every 2 weeks kind of thing. Well, that was like yesterday. So I know there's several definitely highly motivated freshmen, and definitely want to tap into that talent, that motivation. So I don't know. We could just, was it tentatively planned, but maybe what we could do is, I know there's a couple different groups in there, a couple of different SIGs, and maybe they just meet individually. But I would still like to, I know this doesn't apply to you guys so much, but it does for the freshmen, that jacket journey, the jacket journey points, right? You earn points and then you get some kind of prizes. I honestly don't even know what the prizes are, but those meetings are opportunities to do that. So if you do, if you set up a meeting in ACM, like kind of like one that's just with the people that are in your special interest group, let me know. I will put that in the system and get points assigned for those meetings, so that way everyone can get points for that. Okay, so again, any questions with the module 1? Like I said, it's pretty straightforward. We worked on the lab in class, and then you had a quiz. The quiz questions should have been no surprise. You would have seen those before. All right, so now what? Well, now we're going to do a couple different things. We're going to be going back to some of those concepts we introduced in Module 1, and then certainly talking in more detail. And, for things like, hey, the digital values are read from 0 to 255, but then the analog are 0 to 1023. How does that translate? What does it mean? How do I control those values? Those are all things that we're going to talk about right in here, where we create prototypes and sketches that use LEDs, buttons, and potentiometers, or you may just simply hear that referred to as POTS, P-O-T-S. Not the kind you smoke. One.
Dang. Lord.
Okay. Some other things we're going to be looking at. Recall fundamental programming concepts and terminology. You probably will see that objective listed throughout all the remaining modules, and all that is going back to things that we had talked about in other classes, or really reviewing in concurrent classes that run alongside this course, aka CSCI 315. Use the basic parts of an Arduino sketch. Really what we're talking about there are understanding what the setup and the loop do for us, and how we can leverage those to really control our sketch, our program to do stuff. And then, of course, in order to do anything, we have to use control structures and functions. We'll be talking about that stuff today. Today, like I said, I imagine this is going to be pretty much a lot of me talking about stuff. The goal, hopefully, would be to get you guys working on something on Thursday. We'll have to see how it goes. Now, it looks like a few videos. What are the videos here? What? Okay. So they're appear to not be working. So why is that? I thought, all right, well, these are working up here. So there's no reason that these wouldn't be working. I don't know why this is. Maybe I have to because I did just unlock it. Hey. Yeah. So I just had to do a refresh. Okay, so make sure you take a look at those couple of resources in there. Talks about coding, except for the last one, a little bit more in depth. Okay, so we really only have one thing to do. We have these PowerPoints. We had like 3 last time, but they were relatively short. This one's a little bit longer, so you'll see there's more in it. So we'll be slowing down quite a bit as we get toward the end. Functions, there's just some listings of functions that you'll be working with. And then you'll notice there are 2 labs and then a quiz just like last time. So again, if we're looking at, let's say this first lab, control the voltage sent to an LED from a button. When you press a button on your breadboard, the LED should turn on for 7.5 seconds and then turn off and remain off until the button is pressed again. And even in that statement, a little ambiguous. Do I hold the button for that long? It doesn't really matter. You just push it. As soon as that's registered, you want to start a timer. We'll talk about how to do that. Just like the 7.5 seconds shouldn't be stackable, so I just don't push it 10 times within 7.5 seconds, and then it, 10 times 7.5. It'll stay on for that long. Oh my gosh, it really does say that. I didn't even realize that. And that's it. I mean, so again, it's not, you control an LED by pushing a button. It has a timer associated with it. So this one is not too bad. I think we can maybe get to it and work on it in Thursday. Let's see. I know the other one we won't get to, probably talking about today for sure. No, because you have to work with the potentiometer, and that's one of the last things for this module. So that won't be happening this week. All right, guys, and that is a look ahead on what we're going to be doing. And I'm also going to make sure that I cover everything that I have made notes on, because I realized, like I said last time, I didn't do that. And then when it came to the Kahoots, that didn't work out so hot for us, because we didn't even talk about it. All right, let me see here. I think it's this one. Da da da. Okay, so when it comes to Arduino and microcontrollers, like talking in general, programming is definitely a key skill. We need to know how to program. And, you know, if you're just doodling around with one of these microcontrollers, if you don't have an understanding of programming, you're really not going to get very far. It's also important to have at least a basic understanding of electronics, and that was the intent with Module 1. Basic fundamental knowledge, like I have a digital multimeter, I have continuity, I make sure my circuit is all connected. You know, there's things that I can measure, such as voltage, amperage, resistance. Because again, when I'm looking at, you know, if I have all my resistors and I don't keep good organization or track of them, how do I know what the values are? Well, only if I read the bands and know what those values of the bands, the colors on each resistor mean. Nobody knows that. I mean, I would even have to look it up because I had forgotten, except I think I remember what 220 is. It's like red, black, or red, brown, red, black. That's 220 ohms. Let's see. What else are we going to do here? We will control and fade an LED and read the state of a button and a potentiometer. Those are really, like I said, the objectives for this module. And like I said, we introduced pulse width modulation, but we really need to use it. We will be using it. Okay, so right off the bat here, I mean, here's kind of the overview. Like I have no up there. You know, if you didn't take 205, if you didn't take 105 and you just did this class, I think it would be a little daunting and scary. And that's why those classes you need to take first. So here are some of the fundamental programming terminology things. These are the things in that first objective in Moodle, you know, like things about functions, variables, constants, control structures. So these are all things that we've gotten from those other courses. Are there any questions about these? Like functions, for example, you know, create them to do something, and then maybe I get a value returned after it does something. Variables, what's the scope? Am I passing them between functions? You'll see with Arduino, you know, you can make a variable global, and a lot of sketches would have that because maybe you use them in other functions and you don't want to fiddle around with passing around variables or parameters. Constants, we know what that is. So, any questions about this topics or these concepts here? We got it? Okay. Well, before we do that, let's move this over here. As Parker so eloquently put it, thanks for the answers. Let's not do that. Sign in. I'm log in. Oakley dokley. So you want to navigate over to Kahoot, check your password, say whatever. Navigate over to Kahoot so you can participate. Little classic mode here, and we'll turn down the speakers a little bit. Let me Maybe I'll wait a second. Since we don't have a lot of people. All right, let's see. 1, 2, 3, 4, 5, 6. And how many people you're supposed to have in there? Yeah, 7. That works out. Says you're in. Everybody's in. Okay, then. Let's get this started. And good, because I want to see what the experience is on you guys. Because I think it should tell you the question. One. Oh, you do get a. Oh, you just. I didn't even have time to answer. Oh, man. All right, so let's see. This loop executes. Okay, so it's saying loop. All right. So if anyone remembers what these other things are, you're good. Set no value, LCV. Really? Does anyone remember what LCV is? Yeah, right. Loop control variable. That's a blast from the past. Geez, I think that was in 105. But at any rate, yes, a while loop. Ah. Ah. All right, a blank variable is declared outside of all functions, right? And I just mentioned that. I said, oh yeah, you can declare a global, variable, and you can use it wherever. And you'll see that kind of common in a lot of sketches.
Common in sketches?
Common, yes.
Ooh.
Because, like I said, the reality is that a lot of people that do prototyping and playing around with a microcontroller don't really, let's say, have good programming skills. So then it's really easy just to use a global variable. Yeah, I can use that wherever, right?
Could it also be that they just do something real quick, it's not that serious, right? So
Yeah, it's not.
Trying to optimize it the best they can, I guess.
Right, and then that leads to other problems, which is why, when we talk about like the Internet of Things and all these little doodads connected to the internet, if there's not a good solid design in place, it's kind of problematic, right? That's where we're talking about, private member variables and public access to manipulate their values. Well, that doesn't happen if I'm using global variables, right? Like anybody has access to it. So that's kind of not sloppy, but problematic. Yeah, good. All right. Let's see what you got. Number 3. Oh, come on. No, come on. What's missing? Now I can't see the answers. Nah or nah?
You got it.
That was a bad one.
Small.
That was a bad one until we could all see it.
The next time.
Come on, guys, you couldn't see that.
Come on.
All right. All right, let's do the, well, we got two more here, so let's see. All right. Ah.
I went down because I answered so slowly.
You can kind of read that. Oh, well, right there. I had to think about that. Yeah, I know. It's like pressure's on, right? You're gonna like, what? I'm gonna evaluate this, and I think this,
To read it all.
and I think this punctuates, a lot of what we need to be doing in here, and that is, I don't want to say slow down, but I kind of have to evaluate things line by line, right? And just make sure you're doing that as you're working. Because it's rare that you're going to be like, okay, give me the answer in like 5 seconds, right? Oh, it says you have 30 seconds to answer that question. So that was kind of like intentional, but everybody answered it before the 30 seconds was up. So it just moved on.
I answered it before the 30 seconds was up. Awesome.
And as Ben said, right, we could use show media so we can see what's going on. We didn't have to do that for the last one. But if you slow down and you're like, okay, X, I'm passing X as an argument to sub show dub, and then it's outputting, okay, so I know 2 times 2, 4, so it's going to be outputting 4, it's going to go back. Well, the key is that I didn't do that by reference, right? X is not global, so it's not going to modify that value, so X really didn't change, right? So again, that one was a little bit more difficult, but as you slow down and go through it, I think it makes sense, right? Unless there's any questions on that.
I'm a slow reader.
I'm surprised that more people didn't choose 4 and 4 on the new line.
See, I didn't even read the C out in the second.
Well, but a good observation here is that the name of the function is show dub.
Yeah.
Which really,
yes.
it should have been show double the value.
I ran out of time.
All right, so let's go on to the last one. So maybe the last one's like really hard. You probably won't be able to see it.
Somebody's coaching me.
All right, here it is. What will the following code display? The test score equals 100. You have 30 seconds, so it is kind of hard. I'm gonna probably have to make it. I'm gonna have to make it a little bit bigger. The answers are just A, B, C, F. Oh, okay. And then here's your answers.
Your answers now that you tickled.
Yeah.
Well, whatever. Yeah, now that you failed. Yeah, so it was just going through tracing the nested loop, and it's even more misleading in that it doesn't make sense, right? It doesn't make sense if my grade is 100 that I would get an F, and that was done intentionally. But did anyone need to or want to look at that and see why that is the answer? you know, you say, all right, well, that's false, the first one, because it's not less than, it is greater than, but and there. If it was or, then that would be a good one too, to say or, you know, and then you would say, yeah, it is greater than or equal to 80 because it's 100, so your test grade would be B. That'd be an interesting spin on things. Maybe switch up the ors here, ands and ors. But at any rate, just follow it down, all those are evaluated as false to the last one. There's not even an option there for A.
Yeah.
So, yeah. So, good thing no one chose A. All right.
Maybe I'll be-
Let's see. Nice. You do the little.
It's not even-
Guys. So again, that was just some review of some of the things that you should know. Um, well, really, I don't think we do nested loops in 105. I think we just do like loops, and that's it. So really, some of that I think was from 205. All right, cool. So there's our review of that stuff, and that's all we're talking about. Wow, there's a lot of information here. Now, you don't have to worry about reading that. I mean, again, if you want me to, you know, structure variables functions, you can see a listing of some. These are just some common ones. But here's what we're talking about. C++, libraries, fundamentals. Oh my gosh. So what? Well, let me get a drink of coffee. Okay, so there's like a lot to the, you know, the Arduino programming language because, oh yeah, but the nice thing here is we don't need to know everything. So don't feel like you have to go out and learn all the different classes and all of the different functions, you know, everything that's involved with, you know, Arduino and programming in it. That's fine. You know, we'll talk about the important ones as we go along. Some we won't even use. And really, you know, when we say, oh, the Arduino programming language, what is that really? I mean, it's not like you know, you see that publicized, if that makes sense, because all it is, right, it's a subset of C++. So it's basically like a child, if you will, of C++. You know, I was just looking at something today about the top 5 programming languages, and like Scala, I don't even know how to pronounce it. You know, it's like a subset of Java. I mean, there's a lot of programming languages that get notoriety or recognition. R is a similar or a subset of Python. So there's a lot of different subsets of like main programming languages, if you will. So you're not going to really see Arduino programming language, but there's all the stuff that's built into it. Really, when it comes down to it, at the end of the day, the most important aspect of C++ is that you know that it is object-oriented. And again, this is what we're reviewing in 315. Because we really didn't get it in 205. The majority of the sketch code that you'll be reading and writing, that is going to be referencing libraries that contain definitions of objects or definitions for objects. Those definitions for objects, if I'm defining what an object is, what it is made out of, what it can do, what is it then? Let me repeat that. If I am referencing libraries that contain definitions for objects, what are those things? Definitions for objects. What an object is, what can it do? And when I say is, I mean really, what are the variables for that object? So what am I really saying that stuff is that defines an object? Well, the answer's up on the board. Not really, not like spelled out, but you'll see it in that little over in the purple at the bottom. You see how it says include stuff? What are those things? It says include SPI.h, include Ethernet.h. What are those things?
Library.
They're libraries. Yeah.
Header files, header files, header files.
Well, what is in them though? What's in them? The clue? The glue?
Include.
Include is in them?
No.
Okay, what are we doing in 315? Because I think everybody's in that class. What are we working with in there?
The other.
Let's see.
The other command.
The other command? I'm not gonna let this go. Yes, it is a header file. .h is a header file. But what typically goes along with a .h?
And then the implementation file.
Yeah, so you have a specification file and then you have an implementation file. But what you'll find, like I said, we want to separate those out. You'll actually see that they're both combined in a header file, or it's implementation and specification both in one. So really, what those two things are what? I hate to give it to you guys, but I will. They are classes, right? So classes define what an object is, right? So when I'm saying, hey, the object can do all these things, and hey, it contains all of these wonderful member variables, and some of them are private, these are public, all that stuff, those are classes, right? So when I see .h, yeah, we could call them libraries. We import a library, which could contain multiple header files or multiple classes. And that's what I want to illustrate here in a minute, because I would just like to blow your mind a little bit. So let's do that in just a quick sec. So at any rate, going back to this, libraries, objects, these definitions are called classes again. So definitions for objects are just simply called classes. The example shown here, meaning over here, this stuff, the example over here is only one of the classes that are contained within the Ethernet library. So again, this is only one of the classes contained in the Ethernet library. So, for example, IP address, right? So that's only one of a variety. Okay, so I want to look at that a little bit because I want to show you guys some stuff. So let's do this first. Let's go to the interwebs. Now, again, we're not going to delve too much into this because this is like the last module, if you will, working with your Ethernet shield. But what I want to just point out is, okay, the Ethernet class initializes library and network settings. Okay, so there's all these components to your class, right? Set MAC address. You see why? It's for that, and you can look at that. You can look at that member function and say, you know what, set MAC address, it's going to be a mutator, right? There's a class, there's a server class, there's a client classes, and each one of those classes makes sense that they're going to have their own, you know, ways to manipulate the data within them, right? Okay, so what I want to show you is this. Because this is important. When you open up, the thing, when you open this thing up, this is kind of fresh out of the box, if you will. Yep. And so, you know, I think it was Ben was talking about libraries, managed libraries, right? And it's kind of like downloading the index, it's updating what's available, you know, looking for any updates and that kind of thing. Now, you know, this is where I can go to get some that are like published here. What I want to point out is that where these are located, because there's two places, so it's important to know the difference between them because you will need to go into them. So here we go.
So, the library's gonna be the same because it's C++?
What do you mean they're going to be the same?
Like in Visual Studio,
Yeah. So they look the same, right? They're the same thing.
they're the same name and everything?
Yep. Yep.
Okay.
You can open them in Visual Studio. I encourage you to do that. I encourage you definitely to, because you get all the benefits if you're using Visual Studio to write your sketches up that you don't get in this IDE. Although that will tell you errors and stuff, and we'll look at that. But it looks a heck of a lot nicer. You know, tab, I mean, when you hit enter, auto align stuff. You know, I saw a couple sketches from students where it's like everything's all in a line and nothing is really broken up. And it's just because they typed it all and put it all in here, which is nothing more than really a glorified notepad, kind of, you know. So at any rate, what I want to point out though is the difference in where these libraries are stored. Because if you look, documents, you go here, you'll see there's a folder clearly called libraries for your ID, right? So when you log in the computer and you launch Arduino, right, your libraries will be in here. As you can see, I have none. I've downloaded none. We will download some at some point, but I don't have any. But there are ones that are built in, okay? So the location of those are along with the program, okay? So if I go in here, I can look and see, yes, there is a folder called libraries. And then sure enough, you will see those built-in ones, specifically Ethernet. Now, if you notice on that little, on the slide just a second ago, it said that, hey, you know what, I want to include the Ethernet class here, but then I also want to include SPI. So now the question is where the heck's SPI? And if you're, I don't want to say if you're not convinced here, but let's open this up, right? And then let's look at the specifications for Ethernet. I think it might be a little small. Let me make it a little bigger. But right out of the gates, right, you're seeing include Arduino.h, include client.h, server.h, UDP.h. So this is where, you know, then I got to be thinking in my head that I'm going to be referencing things in this code that are not going to be implemented in the Ethernet class, meaning they're going to be in one of those other classes like, you know, client or something else. And right, this is just the specification. This is just telling me what is in this class. You know, Well, this is a virtual function, and you're just going to use read. So those things that are listed online, right, that are member functions of the class Ethernet, you can look in here and see where they are specified, right? Who's the other thing? Oh, yeah. I just wanted to point out that, this, let's see here. I don't even know who developed this. Let's see. Oh, good old Paul. Right? So I don't know. Maybe Paul did this by himself. I don't know. But at any rate, if you have questions about this class, you could call Paul and ask him about it. This class, it's so, how do I put this? It's very efficient, and there's a lot of things in it that, we haven't even talked about. So that's not the point so much as the point is knowing that you may need to get in here. And again, one of those is yeah, that's why I have to include SPI, because in the Ethernet class, I don't include it. So that's why I have to use another one, but that's my point. My point is that if I go back to the slide here, right, this says include SPI and include Ethernet. Well, now I have to find SPI. And I'll tell you that here's your best way to find that. You know that these are the built-in libraries. What you're going to want to do is just search for it. Right? Sure enough, SPI is a folder, but there are individual ones there too, right? Such as Bluefruit LE SPI.stream. Well, that is for firm ATA. So if you're using that component, yeah, you would need to use this SPI instead of one of the generic or default ones. But at any rate, you need to use that. And then what do you notice interesting about this? I can't see that, it's too small. You guys can always say, make it bigger. Looking at SPI, what do you think that means? SPI dot H, SPI dot C. What do you think about that? Think about those apples. We've already identified what dot H is, right? We said, yeah, that's a header file. That's, Michaela said, the specification. What the heck is C? Okay, so what do we typically see? C what?
CPP file.
Right, a CPP file. Do we know what CPP stands for, the file extension? What? What?
C++.
That's exactly right. It stands for C++. That's why it's a CPP file. So then all this is saying is it's a C file. So, yeah. So now you know, the more you know, the more you'll grow. I think that was on Sesame Street. But at any rate, yeah, you're going to see reference to libraries that may be older. Because it's kind of this like cascading effect, like, oh, I need this, and I need this functionality, I need this functionality. Like, nobody makes it all themselves. All right. So I just wanted to do that a little bit so we can get confused. And just to get a general idea of working with libraries, knowing the difference between like user imported libraries versus libraries that are built in with like the program. Okay. And then, again, not that this, I don't want to say it's going to be on the scope of the course here, but, you know, if I go back here, what do you notice interesting about this stuff? Like there's a reference here to Java. Like, what do you think that really means then? I could program in Java too. Oh, I'm clicking on the wrong thing. Why won't this, again, if I'm looking at the location of this is a program. So really, this just means that it's written in Java. The program itself, the IDE is, right? So again, you have this kind of mixture here. Don't get confused. You know, we only really care about, and what you'll be using mostly is getting into the libraries there, right? Cool. Anything else with that? Let me see. I just want to make sure I say everything that I need to. Yeah, we'll come back to this. Well, okay, let's go back to this website real quick. So I want to look at ethernet.begin, right? And how does this work together? So here's the syntax. What can you guys say about, what's the difference here between those member functions? You guys are like, I don't know. What's the difference there?
I guess.
Yeah, a number of
the
parameters.
arguments that each one takes.
So then, ultimately, what does that mean?
They're overloaded.
Yes, they're overloaded. So depending on if I call ethernet.begin with 2, 3, 4 parameters, each respective correct member function we called, right? And that's how I control, you know, which one of these gets called. If I don't have a gateway, well, but I have 3 other numbers in there, then that one's going to be called, right? So it's important. It is important when you're specifying the number of parameters that you know that they're set up this way. As in MAC, MAC IP, MAC IP DNS, MAC IP DNS gateway. Because each one of these things, with the exception of MAC, IP, DNS, gateway, even subnet, those are just 4 sets of numbers, right? Because the first one is an unsigned 8-bit int, right? Where the other ones are not. I don't think that it doesn't, you don't get into this level, but you can go into the library and you can see specifically what arguments are, you know, used inside each one of these member functions. Yeah, 4 bytes. Let's see here. MAC, its array is 6 bytes. Sorry, that was 8 bytes. But again, you see how this number is the same? So those overloaded functions are not going to know the difference. You know, you may have in your head like this is a subnet mask, but instead it's going to be turned into the gateway because you didn't specify that. I hope that makes sense. Okie dokie. Oh, there's an example. Anything else? Okay, cool. That's all I really wanted to talk about. All right, well, we got another long thing here. We should take a break. Take a break for a sec because we have a half an hour, and you know we've been talking about a lot of stuff. I can see everybody's very riveted. It is Thursday. How's everybody else doing? Everybody about ready for a nap? It's kind of cloudy out, isn't it? I always like sleeping when it's cloudy, overcast.
I like sleeping when it's sunny too.
Yeah.
You know what? I also like sleeping when it's raining.
Yeah, that's the best. Raining, I could sleep forever. I actually don't like sleeping at night. I like to stay up all night. Outside of here, like when the semester starts, or even during the week or whatever, I will go to sleep at a normal time. But man, when it's not,
So you're up all night during the summer?
pretty much, yeah, totally. That's the only time we can get away from the kids. Otherwise during the day they're just running around underfoot. So I just stay in bed.
Ah.
Oh shoot! It's the only time I can play Minecraft in peace. They're not in there messing up stuff. Which I haven't touched that since the summer. Dang it, that sucks.
Dang.
And I didn't even get that much action on it because of everything else we had to get done for this semester. At any rate, that all changed. Okay, so let's get back at it, right? Now the only thing we need at this point really to do all this stuff is our Uno plugged into a computer and the IDE up and running. We're not going to use like LEDs, maybe the built-in one, but we're not going to use any external components. We're not going to use resistors and any of that stuff. It's just the Uno for like this part. All right, so I need to go over. We're gonna revisit this stuff. Where did my guy go? All right, this was the thing we were working on last time. Remember, and that is kind of nice in that blink, but this could also be a problem. And what do I mean by that? Because if I go in and I go file and I open into, oh shucks, what did I end up doing? File close. Yeah. But my point is that this could be a problem. We said that before we do anything, we should write a blank sketch out to our Uno, right? We should say file, new, make sure there's nothing in it. It's blank, and let's go ahead and write that out. But what I want to point out is if you bring up one of these examples, such as, I don't know, working with strings and doing character analysis, right? And I go in here and I do stuff with this, well, what's the problem? The problem is that this is an example. What if I start monkeying around in here and playing around with this and changing things up? I've in essence messed up my example, right? So if you want, what I would suggest you do, right, is save it. If you're wanting to manipulate and change an example, save it somewhere else, okay? Let's see, what else? That's important, so you don't mess up all your examples. Okay. Bring up the ID. Okay, this is, yep. So I'm looking at this as my blank. I'm looking at this as my starting point. This is certainly the simplest possible Uno sketch. This code only contains two functions. The first one is setup. And you can see that it has an open and close, left parent and right parent, and there's nothing in there. So it's not doing anything, right? I mean, you don't have any arguments in it. Anything that you put in this function, in here in void, obviously, the sentence gives it away. It runs one time. Anything I put here, it's going to run repeatedly forever. That's an infinite loop, right? The second function is called loop. Nothing in it. Does not require any parameters. Once the code is finished in setup, it'll go to loop. You know, we're used to, right, going like int main, and then that's kind of the start of our program, and then it goes through and does a bunch of stuff, right? That's a little different here. Every single sketch has to have these two in it, these two functions, so you have to have them in there. Okay, so what? Well, let's do something like this. And again, I'm going to, we already talked about this. If I want to get some output here, and this is why, again, it would be helpful, you know, I mean, will this work? Well, actually, will this work? Think back to the Kahoot. Well, remember, you can always say this. You can always say verify. If I do verify, it's gonna say, hey, you got to save this somewhere. I'm gonna save it right here. Gonna go through, I'm gonna verify my code, and then it'll come out and say, hey, you know what? Beep. No, I gotta do that first, right? But I guess my point is that, you know, yeah, this will work, and then I could just paste serial.begin in there, but it looks just sloppy, and it's not nice and aligned, and so yeah. So again, where you may want to use something else besides the Arduino IDE to write your code. Okay, I'm just going to plug in this bad boy. There he goes. All right. All right, so I plugged my Uno in just so I can play around with this. Let's verify this. Gee whiz, that should work. And then we said we want to go under tools, and we said that the thing is the ports. You see how mine's not selected? Okay, well, I'm going to need to do that, right? Because now if I go back here, you can see that you can see it listed. So again, just make sure you're checking this stuff out, because now I'm not saying that the IDE is finicky, but there will be times you'll get an access denied, and you'll just have to try and push your sketch to your Uno again. All right, so I'm going to go ahead and upload this, because we said we want to blank everything out, right? Better work. And done uploading, right? You know, the only thing that I really see as far as some kind of indication that anything's happened was right there. I didn't get an error. All right, now we said we wanted to do this. We want to initialize the serial interface. And we talked a little bit about this. And because that way, now I can see some stuff happening. And then, how do I get stuff to happen? Right? Well, like we said, you know, hello in setup. Right? Now, if I don't put any sort of a delay here, you know, it's going to be a little bit weird, because, well, let's just see what happens. Now, remember, you know, I can't really have that open up. So if I upload that, what? Oh. No, because then it should have given me an error up at the top. What's wrong with that? Say what? All right, so it says what? Hello was not declared in this scope. Okay, so what do you think's the problem with that? You see that?
Oh, yeah.
Yeah, you gotta love that. Because I was lazy and I copied and pasted. I didn't type it out. And do you see how the color changed there? Which I'm not sure why it didn't give me an error up here. But see, now that is a string literal. Okay, great. Hello and setup. All right, I think we're gonna win this one. I'm uploading. All right. And so, I mean, it's just like obviously going to keep going on forever. You can uncheck that box that's auto scroll, very helpful. And you can see it's still going over here. But now I can at least see my first one, hello and setup. Hello, 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 right? And again, auto scroll will give you the updated, whereas I can just turn it off if I want to look. And then you can clear your output, and then obviously you can see it kind of it, depending on what's being output, it gets chopped off, which is pretty cool.
So, how does it know to only run this setup one time? And then it goes to the next one.
Yeah,
And then it keeps going on the next one.
I'm not that smart. You would have to know how. I mean, you could here's what you could do. You could go look in the implementation file for Arduino, which actually is all in Arduino.h anyway. So you could go look in that file, and I guarantee you would see in there, execute once, and then just keep going through a loop. You know what I mean? So that's where you could go to find out. But for me, probably wouldn't be able. I mean, I don't know. Maybe we could find
If
it.
you had two different functions after setup, then it would loop through those two?
No, you would have to call. That's a good point, and that's something we'll need to talk to. But hey, you know what? I have this loop function, but I know basically anything I do in here is going to keep going. You can have functions afterwards, before, wherever functions. You would just have to make sure you call them within the loop. So you have these other functions. You can pass them parameters. You can get stuff back. So you got to just make sure you call them within either loop or within setup. Yeah. Yeah, good point, or good observation. Let's see. All right, so here's what we need to talk a little bit about. Now, the serial class is built into Arduino. Makes sense because I'm using a serial monitor, serial plotter. So that class is going to be built in. So I got some things I can do with it, right? Such as these member functions begin and print len, right? Print ln. You know, and again, we can just think of these classes as really a collection of functions. You know, like I want to do something, so I'm going to say serial.println. And it's really a function, but really we know it's a class that has a member function called println, right? Yeah, and here's the other thing. Like if I want to get, you know, and again, the 9600, not that this is important, but if you change this because you want like faster transmission or something, that makes sense. You need to make sure if you're monitoring it that you change the communication speed over here, right? What would be the difference between print and println? What if I did this? Oh, actually, and this kind of makes sense. I don't want to say it makes sense, but you know, println, print line versus not printing a line, right?
So then you don't have to do.
Yeah, so I don't have to do a new line. Now, if I wanted to, let's say, you know, I have a problem with this statement, right? I can single right click or a whole block, which typically will be the case, and I could just comment on comment. It's the same thing as what we're used to before as far as commenting, so nothing exciting there. If I wanted to, this is going to be helpful. Sheesh. Delay, right? So if I have this function called delay, right? I know that, yeah, I'm going to stop every second. Nah, I don't want to do that one yet. All right, so good. No. And again, yeah, see what happened here? See how it's going like this? What's up here?
You had the slash.
Right. So again, make sure you're reading this. That's why it's important or helpful to verify first, so you don't run into this problem where your Uno starts up, starts running, starts doing things, yeah, it's not right. You know, I rarely do verify in class here, but it's something that you probably shouldn't do. Okay, so I only verified it, so the thing's still running because I didn't upload it. Yes. Then we said, all right, hello. But you see that delay there, right? Cool. The delay will be very helpful, like troubleshooting wise. So make sure you know how to use it. Okay, so we're going to do something a little bit more interesting here. Like I said, we could look up millis, but it's just another way to delay, really. Well, oh, darn it. Probably a dang homework question. Millis. Okay, so, right, you know, we're not talking about, so we do have to talk about millis. Okay, delay will stop execution, where millis tells me, hey, how long has it been since my board's been up and running? Because since we don't have a clock, like an internal clock built in, how do we know, you know, what day it is? How much? All we can really say for sure is how much time has lapsed between the time that Uno was powered on and currently when you call, in this case, time. So if I give you the output of time, it'll give me what, you know, how much time has been running, the board's been up and running. Okay, so, yep. All right, we did need to mention that. So, yeah, is it ideal for keeping track of time? No, but it is a way to keep track of like how long something's been, you know. If you get the current time, let's say that's like 1,000 seconds, okay? And then you assign that to a variable. Then you wait. You sample that same variable again, you say, then now time equals millis. Whatever that new time is, if that's 2,000, that gets assigned to time. You can then make an estimation then of how much time has lapsed since the last time you called time. All right, that should make sense. So think of millis as a timer. All right. All right, so int do a calc, do some stuff there. So there's quite a few things here to talk about. I'm going to go through and, right, I'm going to create a function. And let's do what Ben had suggested, which is, I'm going to make my own function down here. And am I going to have anything returned with it? Notice, what happened there. Do a calc, but it's like, I don't know if that's, what is that? Hold on. And see, it doesn't even put a nice ending, curly bracket there for me. So again, that's a lot of manual work here if I do it this way to make it look good. And, you will get dinged on that, especially when you get into control structures and everything's in one line. Yep. So now what I'm going to do is I'm going to do a print every time I do a calculation. And I'm just going to print out the result of 1 plus 1. And, I'm going to say not, but, every time I call this, the calculation is going to be the same, right? So I probably want to put in a variable here. Yeah, so right between the built-in and the built-in and the ones you want, remember? So what's going to happen here? We have keywords. So yeah, good point. So if I do that, and let's just go up here. Right. If I say 4, notice how 4, we know that that's part of a, some kind of for loop, right? So we know that that's a reserved keyword. Whereas, int, well, yeah, we know that that's, obviously reserved, or, if I say, float or something like that. So you can see the different colors. When it comes down to, and what Parker's saying is, hey, this is not the same as the other, right, functions. Does that mean it's a bad function? There's something wrong with it? Why wouldn't you want control?
Actually, I really accidentally clicked that.
Okay. Like, no, you can't have control. So things like loop and the other function, yeah, those are reserved keywords. So that's why they're kind of puke green color. Yeah, good call though. No, and again, we'll talk about this stuff because yeah. So if I do that, right? Do a call. Yeah. Do a calc. Right. Yeah, it's not that picky. And what I mean by that is, this is really cool stuff, guys. I'm telling you, at 3:30, we'll talk about how we can evaluate basically the syntax. The syntax is the control of everything. It's really cool stuff. Just hold on to your seats because it gets really cool. Because, white space does matter in some circumstances, unless, of course, it's right after an identifier. Because an identifier, I go until I see another character that is going to be a delimiter to tell me that identifier is done. Right? So yeah, you could have a lot of spaces in there. And then what's really cool is there's only a certain subset of identifiers that I will allow before my compiler gives me an error. Yeah. So really cool stuff. Again, hold that thought for about a year. Okay, so I can see the time here. We'll save this for Thursday. Bring your Uno. I want you to definitely play around a little bit with this while we're doing. Yeah. Well, wait. Today is Thursday, right? Holy crap.
Yeah.
Okay. Well, we did a lab on Tuesday, so now I don't feel so bad. But on Tuesday, bring your Uno, plug it in, play around with this a little bit, and then see what kind of errors you can come up with. We'll be talking more, and then the next thing, oh shoot, I gotta get going, guys, is going to be actually input and output LED. So we'll be using this stuff, so we'll definitely get to this. So bring this on Tuesday. Or Monday, god dang it, bring it on Monday. All right. Been real. We'll see you guys tomorrow virtually. That's what I'm thinking. We'll see you on 3:15 tomorrow. Have a good day. Don't get rained on. Yes.